All right, so we are going to talk about another type of injury that can happen and look at how it can repair itself, and that is fractures or breaks in the bones. And so, what is this process for repairing fractures? So, the first step is our hematoma formation. So a hematoma is a collection of blood. Typically we see it under the skin surface, but in this case we're actually seeing it within the bone itself. So you can see in panel A here as we have this blood forming, puddling or pooling within this region of the bone. And it's kind of being contained here as far as the periosteum is keeping it in as much as it can, but any breaks in the periosteum and it will actually leak out as well. So you get an increase in the blood, which will increase the signaling for chemicals to come. Without having things come to heal the area itself, we actually would have necrosis of the bone ends or dying of the bone ends. So it's needed for us to be able to do that. So we're forming that hematoma. It's signaling for other chemicals to come in the inflammatory process because otherwise the tissue or the bone would die. So then we move on to our second step. The second step is the fibrocartilaginous callus formation. So cartilage is formed at the fractured site. The bone begins to form directly around that area, and usually it's along the periosteum layer. So we've got bone that's starting to form or cartilage that's starting to form. Then we have a lot of growth of blood vessels. So we get a lot of vascular growth that is coming in order to bring more nutrients to the area. And really, when it comes down to it, micromotion at these fracture sites is really vital for us to have this callus formation. So we need to make sure that there are some micro movements that are happening in order to continue this bone growth. The active cells that we're talking about here are all of our inflammatory cells for like the phagocytic cells and such, and also the healing cells like the fibroblasts that are laying down new tissue, as well as osteoblasts. And osteoblasts are the cells that are building new bone. So osteoblasts build bone. Our next step in the repair of fractures is the bony callus formation, also known as the hard callus formation. So we had soft calluses forming on the previous slide, and now we've got hard calluses forming. So the cartilage that's at that fractured site is now beginning to calcify and become harder. The calcification continues until the bone ends ultimately are reunited and are joined from inside wherever the break was. There's still an increase in blood flow to the area here as it improves the healing. It's bringing more nutrients and clearing away debris. And then we have our fourth step, which is the bone remodeling phase. And here, the hard callus is remodeled into mature bone. So what once was kind of joined together in what we saw on that last page, in which you can still see where the fracture was, it starts to remodel into a new mature type bone and actually is more smooth in nature. We also have a lot of osteoclastic reabsorption that's happening. So osteoclasts will break down bone. So it's reabsorbing some of those extra layers of bone in the process of this remodeling nature. Blood supply starts to return back to a normal amount. And then mechanical forces are really needed for us to be able to do this remodeling. So we need to have mechanical forces and in this process, which is why often after you are out of a cast, they will put you into a walking boot. So they still want to protect it, but they want you to be able to put weight on it in order to start remodeling that bone. And that's what the walking boot is for. So here's an example. Here we've got a picture right here of where the break was. And then we started to reform. We had the soft callus formation, and now we're at the hard callus formation here. But you can see that there's still this break. You can tell that there was a fracture to this bone. But as we walk around on it more and put more weight on it, it starts to remodel. Those osteoclasts will break down the bone. Osteoblasts are building up bone in new areas, and it works together to be able to remodel it so now it's nice and smooth and has integrity. So, we've talked a lot about ibuprofen or other nonsteroidal anti-inflammatory drugs on the inflammation process. And we've talked about how it does tend to delay healing or extend the healing process when we're dealing with inflammation in general, any kind of an injury. And this is actually a great picture of what it looks like when we're trying to do bone formation and bone remodeling again. So what we can see going across here, we've got no drug was used in this circumstance, and then different types of nonsteroidal anti-inflammatory drugs were administered. And I believe this is in a mouse femur is what was broken. And we're looking at that healing time of 2 weeks, 3 weeks, and 4 weeks of what would these things look like. So just to put a little context of things, the red that we see right here, that is bone. When you can see this orange to reddish color right here, this is our cartilage, our calcified cartilage. The cartilage that is not calcified is these darker blue areas in here, almost to a deep purple. And the lighter blue of what you can see is sometimes muscle, but a lot of it is just fibrous tissue that is building up. So you can see that lighter blue that's right above that. So when we take a look at no drugs given, so this is no non-steroidal anti-inflammatory drugs given, we had the break right here. It's starting to heal. We build up that fibrous tissue as it's trying to start to heal the process. Cartilage is starting to form. It then begins to calcify at around 3 weeks or so. And then by 4 weeks, what you'll notice is that that calcified cartilage or the cartilage has now fully calcified. So here it was still forming as the cartilage you can see in the dark blue. And here, as it's more of this orange to red, we now have calcified cartilage. And ultimately that will start to reduce into bone as well. So what happens when we give drugs? Well, what you'll notice is that we get that cartilage that's forming, but that cartilage is not calcifying over time. We also get an increase in that fibrous tissue instead of having that calcification that's happening. And you can see that across every single one of these conditions in which medications were given. And I feel like that is a really powerful picture of how this was occurring and delaying the healing process, where you can see like good healing taking place when there's no drugs administered. But in every other case, when drugs were administered, at 4 weeks, it was nowhere near the healing process that it was with no drugs, and was in fact kind of more similar to what we saw after only, like halfway through. So I think that's just a good, powerful visualization of that. I also want to show you this same type of a thing in which we're looking at these different drugs, right? Having no drug versus other types of non-steroidal anti-inflammatory drugs. And again, we're looking at 2 weeks. This is 4 weeks and 8 weeks on the bottom right here. With no drug, you can see there's a little rod in this little femur of our mouse here. But you can see that the forming of the bone is coming, and you can see that calcification that is occurring on either side of that rod. But now when we start going to where we're looking at it with our drugs on board, you'll see in each case, this is not forming. And in this case, you can see that the break is still completely there after 8 weeks. with this particular drug, whereas here we've got fully calcified, we've got bone reforming, we've got good integrity and continuity of the bone itself. So again, just showing you what these differences look like when we are delaying our healing process by taking things like ibuprofen or other non-steroidal anti-inflammatory drugs.